In this video, we're going to look at how we can use scale drawings to find the resultant force on an object. Let's imagine that a man on his bike is pedaling to create a force of 4 newtons northwards. At the same time though, a strong breeze is blowing him eastwards with a force of 3 newtons. We can represent this situation on a grid, where the cyclist is this orange dot, and the forces are shown as a 4 centimeter arrow upwards and a 3 centimeter arrow to the right, so that each newton is equal to 1 centimeter. Now that we have a scale diagram, we can find the magnitude and direction of the resultant force by placing these 2 vector arrows tip to tail, which we could do by moving this one up here, so that the tip of the north vector is just touching the tail of the east vector. Then to find the resultant force, we just draw a line from the starting point over to the end point. And because our drawing is to scale, we can just measure it with a ruler to see how long it is. In this case, 5 centimeters. And then we can convert that into newtons using our scale. So because each centimeter is 1 newton, our resultant force would be 5 newtons. To find the direction of the force, we just measure this angle here with a protractor, which would give us around 37 degrees. So we could say that the resultant force is 5 newtons at a bearing of 37 degrees from north. In some cases, the forces might all balance, in which case the object will be at equilibrium. For example, if we had a particle that had these 3 forces acting on it, then to find the overall force, we just arrange the 3 arrows tip to tail like before. And because they all join up perfectly like this, it means there must be 0 resultant force. Don't worry about arranging the arrows in any particular order though. As long as you put them all tip to tail, then you'll be fine. For example, we could have arranged them like this instead. They still form a perfect triangle, which means there's no resultant force. The last thing we need to look at is how to resolve vectors. This is basically the opposite of what we've been doing so far in this video. When you resolve a vector, the aim is to split it up into its horizontal and vertical components. And to do this in practice, we need to use a scale drawing again. Let's imagine that we have a toy car, and that we're exerting a force of 50 newtons on it to push it up the ramp. How do we resolve this force? Well, if we make our scale 10 newtons per centimeter, then we could represent the 50 newton force with a 5 centimeter line at the same angle as the ramp. Then all we have to do is draw a horizontal line down here and a vertical line up here, putting an arrow on each of them so that we know their directions. Then we just measure them with a ruler to find that they're 4 centimeters and 3 centimeters. And so looking at our scale, we can convert them to find that they must be a 40 newton force to the right and a 30 newton force upwards. So we've now resolved the 50 newton force into its horizontal and vertical components.